in the ocean near Los Angeles, on a lonely mountain in Japan, off the east coast of Canada, a plane crash can reduce an enormous jet plane to mangled pieces. The cause is buried somewhere in the wreckage.
In the business, we refer to often finding the golden nugget.
A modern jet plane is made up of hundreds of thousands of parts. A failure in any one of them can lead to disaster.
A missing screw can jeopardize the safety of flight.
Constant checks keep planes flying and passengers safe. A single oversight can end in tragedy.
Mayday! Something exploded. Help me, hold it, hold it!
Summer night in Phoenix, Arizona. It's 11 o'clock, but the maintenance workers at Southwest Airlines are just getting started. Tonight, they're going to open up a state-of-the-art Boeing 737-700. Almost 40 inspectors and mechanics are going to spend the night making sure the plane is fit to fly.
Without proper maintenance, airplanes don't fly. Pilots are usually the focus for the operation of the airplane. But maintenance has an equally high priority role in the safe operation of any aircraft.
To keep airplanes in peak condition, they get more health checks than most passengers.
It is a very intricately weaved web between the operation of the airplane and the maintenance of the airplane and the management of the airplane.
Passenger planes are examined every time they come to a stop. This is the A check. A brief walk-around inspection turns up the most obvious problems. The more intensive work is done at set intervals. These are the B and C checks. Tonight, workers are performing a C check. From start to finish, it can require hundreds of man-hours of work. It all has to get finished tonight, so the plane is back flying in the morning. It's a massive challenge, because modern jets are made of hundreds of thousands of individual pieces. In 1903, when the Wright brothers took their historic first flight near Kitty Hawk, North Carolina, their plane had some 1,500 parts. A 737 has more than 360,000.
You have to ensure that every one of those components is doing its respective job. It doesn't matter how big the part is, a missing screw can jeopardize the safety of flight.
It's a lesson the aviation industry has learned the hard way. January 31st, 2000. On board Alaska Airlines Flight 261, the situation is desperate. Operating a damaged plane, the captain is trying to land at Los Angeles Airport, but the aircraft is not responding to controls. The MD-83 is plunging towards the Pacific Ocean. Other pilots flying nearby report the nightmare scene back to LA Air Traffic Control.
Yes, sir. He is definitely in a nose-down position, descending quite rapidly. Definitely out of control.
Plane's inverted, sir.
Okay. Yeah, he's inverted.
Push the blue side up! There! Here we go!
And he just hit the water.
Yes, sir. He hit the water. He's down.
Flight 261 crashed off the coast of California at over 400 kilometers an hour. All 88 passengers and crew are killed. Investigators from the National Transportation Safety Board begin their work quickly. The cockpit voice recordings provide some of the earliest clues.
We have a jam stabilizer, and we're maintaining altitude with difficulty.
We immediately suspected some problem in the tail of the airplane, which is where the controls are. Something was wrong back there.
Investigators examine the MD-83's horizontal stabilizer. The stabilizer controls the plane's pitch. its ability to tilt up and down. As the stabilizer moves up, the plane's nose tilts down. As the stabilizer moves down, the nose moves up. In the MD-83, a motorized jack screw on the tail moves the stabilizer up and down. When investigators recover the tail from the crash site, they make a puzzling discovery.
The jack screw wasn't mated with the nut that it screws into. It was just by itself, and the nut was found in another piece of structure a few feet away from where the jack screw was. To have a screw separate itself from a nut with very thick threads surprised us.
Without the jack screw, the stabilizer was beyond control. Without the stabilizer, the plane was doomed. The investigators very quickly figured out how the accident happened. Now they want to know why. The answer is tragically simple.
There was no lubrication or visible grease on the working area of the screw. That was surprising and strange.
The Federal Aviation Administration orders an immediate check on all MD-80s in the USA. At Alaska Airlines, the jack screws on 6 of its fleet of 34 MD-80s fail inspection. Investigators discover even more alarming evidence as they go through the carrier's maintenance records. Mechanics at Alaska Airlines report that they are under tremendous pressure to cut corners to keep the planes flying.
We interviewed all the mechanics who had worked on these airplanes. We knew that they had been falsifying records or not doing the work they had indicated.
To survive an economic recession in the 1990s, Alaska Airlines slashed their maintenance regime.
With air carriers, especially those that may be economically strapped, they're going to stretch inspection cycles to the maximum. The FARs, the Federal Aviation Regulations, set a minimum level of safety. Now, if you're going to operate on a shoestring, you're only going to meet that minimum level of safety. If I'm a good carrier, or I want to be a good carrier, and I want to show that we're going to operate at the highest levels of safety, I'm going to typically exceed the minimums. It's going to cost more, but I'm going to exceed it. A lot of companies that say, wait, the regulations only say I only have to go to here, that's what I'm going to do.
Jack screws in the company's fleet had been inspected every 500 to 700 flight hours. But in 1996, to cut costs, Alaska Airlines began checking the jack screws every 2,500 hours. At the same time, they doubled the average daily use of their fleet.
If you had 600 hours between inspection points and greasing points, we have no chance of ever having a metal-to-metal contact situation. But if you put that out to 2,000 hours or 2,500 hours, now what you do is eat into some of these protective stages, these barriers that we have towards catastrophic failure.
Proper maintenance becomes even more critical when there's no backup to a component. On the MD-83, there was no alternative if the jack screw failed. So proper maintenance was a matter of life and death. But in the aviation industry, it's also a matter of dollars and cents.
There's a lot of pressure in the airline industry when you look at it, whether you're hauling boxes or hauling people. The fact of the matter is that competition is stiff. And how do you get the competitive advantage against the next guy? How am I going to get more for less? And a lot of times it's labor, the other times it's maintenance. If I can stretch the inspection to 500 hours instead of 400 hours, that saves me a lot of money.
To stay afloat financially, Alaska Airlines put countless lives at risk. But disaster can erupt even when an airline doesn't cut back on its maintenance regime. It's past midnight in Phoenix, Arizona. A maintenance crew works through a 737-700. They're performing a so-called C-check, one of the most detailed inspections any plane can go through.
We work overnight because that's when nobody flies. Better for the airline to keep the airplane on ground overnight to fix them up.
Tonight, 339 individual inspections are set to be made. Each one of these is tracked by computer. Anything that comes up yellow is an unscheduled procedure, a problem that's just been spotted.
Unscheduled maintenance are those kinds of things typically that people will experience with their car where they're driving down the highway and all of a sudden the air conditioner doesn't work. Well, the same with an airplane.
Tonight, the inspectors discover a tire on one of the main landing gears is worn out. They add it to the list of unscheduled maintenance items. It has to be replaced before the plane goes back into service.
Obviously, the stakes are extremely high. Every night we come to work and try to do our best job possible. Make sure everything's in working order so people get to where they need to go.
But sometimes, despite all the maintenance, the worst-case scenario comes true. A simple repair can unexpectedly lead to disaster. August the 13th, 1985, Mount Osutaka, Japan. This is the wreckage from the deadliest single-plane disaster in aviation history. JAL Flight 123 crashed the night before, killing 520 passengers and crew. Only 4 people survived. Because the 747 jet was built in the United States, the National Transportation Safety Board joined the investigation.
When I arrived in Tokyo, the atmosphere in Japan was extremely stressful. The news media were everywhere. There was a tremendous amount of anger.
Soon after the crash, experts get a helping hand from an amateur photographer. He managed to take a picture of the 747 minutes before it crashed. The picture reveals that JAL Flight 123 was flying without its massive tail fin. The tail fin houses critical control surfaces, like the rudder, as well as tubes that carry the hydraulic fluids. What force could be strong enough to tear off the tail fin? Digging through the 747's maintenance history, investigators discover that 7 years earlier, the jet had landed with its nose too high. The tail hit the ground and scraped along the runway. The rear part of the plane had to be repaired, including the pressure bulkhead. Japan Airlines called in Boeing technicians to help repair the cracked bulkhead. After this unscheduled maintenance, the 747 was given a clean bill of health and flew for another 7 years. But this bulkhead becomes a prime suspect for the investigators.
Well, we had an idea that we wanted to find the rear pressure bulkhead because we had a flight attendant who had been interviewed that described an explosion in the back of the airplane and she could see out, so we wanted to focus on the bulkhead.
During his investigation, Schleid finds a piece of the panel that had been spliced into the bulkhead 7 years before. The mystery of Flight 123 is solved. The 747 went down because of a faulty repair.
The repair had in fact not been done correctly. There was only one row of rivets holding that joint together, where there should have been 2 rows of rivets holding the joint together.
With only 1 row of rivets straining to hold the repaired panel in place, this was a disaster waiting to happen. Especially because this was such a busy jet.
This particular airplane was used in Japan on a domestic operation, so it made multiple takeoffs and landings on domestic operations, unlike most 747s that make long-range hauls. So this was considered a high-cycle airplane.
Investigators calculate that with the repair job, the bulkhead would survive approximately 10,000 flights or cycles. But on the day of the crash, the 747 had already racked up over 12,000 cycles. On 747 jets, the cabin is pressurized, but not the tail. During flight, the pressurized cabin air presses against the repaired bulkhead. After some 12,000 cycles, this pressure stretched the faulty repair to breaking point. The highly pressurized air blasted into the hollow tail fin and blew it off. Losing part of the tail crippled the plane's hydraulic systems.
The Boeing 747 had 4 independent hydraulic systems to power its systems, so it had quadruple redundancy. Unfortunately, these 4 lines came together in the lower part of the spar, and when it separated, it sheared those 4 lines. All 4 hydraulic systems were depleted.
Both hands! For some 30 minutes, the crew tried to fly their 747 using only thrust. This is like trying to drive a car using only the accelerator. No steering wheel, no brakes. Despite their heroic efforts, it was a losing battle. All this death and destruction boils down to a missing row of rivets. Why had the growing metal fatigue in the bulkhead remained undetected through 7 years of scheduled maintenance and inspections?
The primary inspection method for the bulkhead area and the seams was a visual inspection. And at heavy maintenance periods when they would take the insulation out off the walls and everything and off the bulkhead, they would do a detailed visual inspection.
And during subsequent maintenance checks, the faulty repair was never found. Two decades after JAL Flight 123, airlines are constantly looking for hidden flaws that aren't visible from the outside. Back at the Southwest Maintenance Hangar, inspectors are using a borescope, a tiny flexible camera, to inspect the engines. Engines are the heart of passenger planes. If they stop working, pilots don't have the option of pulling over to the side of the road.
Yeah, there we go. In this area, we're looking for cracks, looking at the blades, the rotor blades, and looking for missing material off of them. You know, any hot spots that have worn through the metal, cracks, radial and axial cracks.
Any kind of crack or trace of metal fatigue in any of the fan blades could spell disaster.
Takeoff check below the line. Okay, your lights.
August the 21st, 1995. Atlantic Southeast Airlines Flight 529, an Embraer Brasilia, is about to take off with 29 people on board. It's bound for Gulfport, Mississippi.
It was, at the time, the fastest, sleekest turboprop around.
Before the plane even reaches its cruising altitude, something seems to explode outside.
The sound of that was tremendous. It was as if someone had taken a baseball bat and hit an aluminum garbage can as hard as they could. It was just a gigantic crashing sound. The airplane immediately lurched to the left.
No matter what the flight crew tries to do, the plane pulls violently to the left.
Hold it.
Over there.
The captain and co-pilot are pushed to the brink of their experience.
Help me. Help me, help me, hold it, help me, hold it!
Atlantic Southeast Flight 529 crashes near the small farming community of Carrollton, Georgia.
Yes, we have a plane crashed in our backyard. A plane crash?
All 29 people survive the violent landing. But 10 passengers eventually die from their injuries. Called into action, the NTSB creates teams to examine various parts of the plane. Jim Hookey, an aerospace engineer, is in charge of the propeller maintenance group.
We came along a lot of pieces of the wing, came along the propeller assembly that was missing one part of the blade.
The blade broke in a very specific fashion, leaving behind all the telltale signs of a fatigue fracture.
A fatigue fracture tends to be a very flat fracture. It also has what we call beach marks radiating out from the origin. So you see these radiating concentric rings coming from the origin of the crack.
Hookey had good reason to focus on the broken propeller blade. 17 months before ASA 529, identical propeller blades broke on separate flights over Canada and Brazil. Fortunately, in both cases, the aircraft managed to land safely. The manufacturer of the propeller was Hamilton Standard. Hookey and his team start combing through Hamilton Standard's maintenance records. They're looking for anything out of the ordinary.
It's whatever's abnormal. You really don't know what you're looking for until you find it. But you just go through, and there's a lot of routine maintenance is done, regular inspections, A checks, B checks, C checks. And then there's the non-routine maintenance that occurs if something is broken or a truck hits the airplane or they have a bird strike or something like that. And it's those that you look for.
The maintenance records revealed that the broken propeller blade had earlier problems.
We found out that propeller blade had actually been removed from service once already for a crack indication. And that became the first clue about there may be a problem with that propeller blade and those inspections.
Deep inside the hollow propeller, investigators find what they're looking for. In the hollow interior, or taper bore, weights are inserted to balance the prop. They're kept in place by a cork. This simple cork was the trigger in a deadly chain of events.
About 95% of the cork that's produced in the world is used by the medical industry. And for aesthetic purposes and for sterilization, they like to have the light color. So the cork is bleached with chlorine.
The NTSB discovers that moisture inside the propeller caused the chlorine in the cork to leach out and corrode the propeller's aluminium alloy. They also notice something else on the broken blade. On the inner surface, extending about 4 centimeters from the fracture, there are a series of sanding marks. Going through the blade's repair records, Hookie notices the initials CSB, Christopher Scott Bender. This technician worked at a Hamilton Standard repair facility. When Christopher Bender watches news of the accident, he learns that the investigators are examining the Hamilton propeller.
And as soon as I heard that, my heart just sank. I was like, I think I might have even cried a little bit because I was just emotionally overwhelmed that, something I had put my hands on, the procedure that somebody trusted me to do failed, and because of that, somebody had died.
After discovering that it was Bender who last worked on the deadly propeller blade, the NTSB now has to find out how the blade had passed inspection at Hamilton Standard. Investigators ask Bender to perform his standard maintenance technique on the propeller.
He demonstrated how he would go down into the barrel of the taper bore with a fiber optic borescope and look for cracks. And therein lied one of the primary problems. The borescope that he was using had a bright white light that would put a lot of glare back into the inspector's eyes, really did not lend itself to the inspection that was required.
And investigators also find a gap in Bender's training.
He had never been shown what a crack would look like. He was just told to find a crack, and he would look for a crack.
When he was examining the propeller blade, Bender had been unable to detect any evidence of corrosion. He then did what he'd been told to do: polish the inside of the blade.
He was given a directive to use a repair to blend out the inside of the taper bore. He blended it out, he did an inspection, and the blending that he had done had roughened the surface, so it actually masked the indication of the crack in the subsequent inspection, and the blade was returned to service where the crack continued to propagate until it ultimately reached critical length and separated.
The draft accident report we present to you today involves Atlantic Southeast Airlines Flight 529.
According to the NTSB, by polishing the blade, Hamilton Standard had unwittingly removed all traces of the crack. Even a later, more thorough ultrasound examination could not detect it.
Life with no inspection.
The company that manufactured Flight 529's propeller is now renamed Hamilton Sundstrand. Its inspection and repair process was made more stringent, in some cases exceeding FAA requirements. Flight 529 was the last time one of its propellers failed in flight.
I wish this had never happened. I wish I could go back in time and fix it and take care of it, that it didn't happen.
Out of the thousands of parts on board an Embraer Brasilia, a simple small cork was the key to a horrific accident. ASA Flight 529 underlines the critical need for proper maintenance. But sometimes maintenance can create the potential for disaster when a new component is installed into an older airplane.
London Center, Swiss Air 111 Heavy is declaring pan, pan, pan. We have smoke in the cockpit.
It's early morning in Phoenix, Arizona. Southwest Airlines engineers are continuing their scheduled maintenance of the 737. Southwest is unique among larger airlines. It flies just one kind of plane, the 737. Tonight, engineers are working on a 700 model, one of the newest 737s. But the company's very first 300 model, bought in the mid-1980s, is still flying.
You can still operate an old airplane as long as you have inspection protocols. When you look at some of the cargo carriers, they're operating airplanes that are 30 and 40 and even 50 years old. They're still reliable airplanes. They've been maintained, they've been retrofitted with modern-day equipment.
Updating older planes is a standard part of maintenance. But sometimes installing a new component in an older plane can lead to tragedy. Inside this makeshift lab are the shattered remains of Swissair Flight 111. On September the 2nd, 1998, the passenger jet crashed off the coast of Nova Scotia, Canada, killing everyone on board. Recovered from the seabed, the debris is overwhelming. There is almost 250 kilometers of wiring alone.
In Swissair, we've had about 2 million pieces of airplane, and we pretty much almost had to look at them all.
In the business, we refer to often finding the golden nugget. That's saying, aha, there's the cause of the accident.
Somewhere in this wreckage, investigators hope to find that golden nugget. The one piece that will reveal the reason why Swissair 111 crashed into the Atlantic Ocean. The cockpit voice recorder gives investigators their first critical clues.
Do you smell something? Yeah, what is that? Go have a look, I'll take the controls. Roger, you have control.
The first officer checks the area around the air conditioning vent. Nothing seems wrong.
Don't see anything, Ernst. There's nothing up there now.
Captain Zimmerman is troubled by the smell of smoke.
There it is again.
He starts to divert the plane to the nearest airport.
Find the closest place to land, Stefan.
He radios air traffic control in Moncton, New Brunswick.
Moncton Center, Swissair 111 Heavy is declaring pan, pan, pan. We have smoke in the cockpit.
Pan, pan, pan is an international term used to notify air traffic control of an urgent situation.
30 miles to fly to the threshold.
It's one step below declaring Mayday.
I guess Boston, we need for...
Swissair 111 is directed to Halifax and starts its descent.
Okay, can I vector you to set up for runway 06 at Halifax?
The pilots appear calm and in control. Halifax is just 20 minutes away.
They want us to turn to the south. At that point, everything was normal. I gave the pilot an initial descent, and he requested to level off at an intermediate altitude to get the cabin in order for the landing, which took to mean that they needed to pack away dinner trays and things like that.
Cabin bus off! Cabin bus off, roger.
But the seemingly controlled situation on board Swissair Flight 111 escalates into a full-scale emergency.
Autopilot, disconnect! We are declaring emergency now, Swissair 111 at time 0124. All right, screens are down. I'm flying on standby instruments, maintaining 300.
Shortly after declaring an emergency, the plane goes silent.
It was probably one of the most helpless feelings that any individual can have, not being able to do anything but just sit and watch the target and hope that it would turn back toward the airport. And of course it didn't.
At 10:31 p.m. Atlantic time, residents of Peggy's Cove hear a devastating explosion. From the cockpit voice recorder, investigators know they're dealing with a fire and not a plane that was malfunctioning.
We found no anomalies or no problems in any of that flight data that suggested there was a problem with the aircraft.
Investigators work their way through the hangar of wreckage recovered from the Atlantic Ocean. Finally, they find scorch marks, which reveal that the source of the fire was in the back of the cockpit, directly behind the first officer. Following this trail leads the team to an unlikely suspect, the entertainment system in first class. The Swissair MD-11s provided first class with one of the world's most sophisticated entertainment systems. Passengers in first class could choose their own movies, access the internet, and even gamble. This entertainment system was not part of the original MD-11 design.
The system had some major deficiencies. It was getting very hot. It drew a lot of power. And thereby, for example, raising the cabin temperature considerably, because it was always running. They did not install a simple off switch, nor did they install appropriate cooling systems.
Anytime you have an electrical system or you're putting an aftermarket install into an airplane, you run the risk of compromising the integrity of the aircraft itself as it was originally designed.
When informed about the flaw in the wiring, Swissair immediately disabled the entertainment system on the rest of its fleet. But investigators discover that another piece of the jet had helped the fire spread with alarming speed.
And in this instance, we did discover a wire that arced in that way, and right next to it was some very flammable material called metallized polyethylene terephthalate covering material that covers the insulation blankets.
This polyethylene insulate was common on commercial airlines around the world. It had somehow passed the industry's flammability tests, which require materials to self-extinguish after a reasonable period of time.
This thermoacoustical material that was in this aircraft was very flammable, even though it passed a test. It does sustain and it does propagate flame.
The fire spread quickly from the cockpit back into the first-class galleys. Some metals showed heat damage from temperatures as high as 1100 degrees Fahrenheit. Less than 12 minutes after the crew declared a pan-pan, the fire disabled all electronics in the cockpit. In the aftermath, Swissair removed the flammable insulate from its entire MD-11 fleet. The rest of the industry was required to follow suit. In Phoenix, Arizona, flight engineers continue their C-check on the 737. It includes testing the plane's rudder. The rudder is one of the jet's most vital control surfaces. It allows a plane to turn left and right.
Okay, Seabass, rudder should turn.
All right, go ahead. Hey, yeah.
A problem here could have terrifying consequences. In fact, despite years of proper maintenance, a problem with a tiny component with the 737 rudder killed more than 100 people. Not even the most diligent maintenance workers could have spotted it. March the 3rd, 1991. United Flight 585 begins its final approach into Colorado Springs.
Another 10-out game.
3 flaps.
Oh, God, stop! 15 flaps! 15!
Going up.
Oh, my God! Oh, my God! Oh, my God!
All 20 passengers and 5 crew are killed. Investigators from the National Transportation Safety Board descend on Colorado Springs.
My first sense that it was going to take some time and to investigate the accident was the damage that we saw in the parts.
An aerospace engineer by training, Greg Phillips is in charge of investigating United 585's flight control systems.
We focused in after eliminating other flight control surfaces that we thought could contribute to the role. We started looking at the rudder.
But investigators face a critical obstacle. Most of the plane's parts are too crushed or burned for testing. Luckily, one vital component is still reasonably intact. This is the Power Control Unit, or PCU. Used constantly during flight, especially during landings, the PCU performs like a car's power steering. When the pilot pushes on a rudder pedal, the PCU uses hydraulic fluid to convert the gentle movements of a pilot's foot into the pressure needed to move the 737's enormous rudder. The heart of the PCU is the dual servo valve. This valve is roughly the size of a soda can. It contains 2 extremely thin slides that glide past one another. These slides direct the flow of hydraulic fluid which moves the rudder. When a technician opens up the power control unit, it seems to be in working order.
We
We didn't have any absolute indication or information that we could point to that said the rudder power control unit, the servo valve, or any part of that flight control system caused that accident.
It's a burst. For only the fourth time in its history, the NTSB releases a report that does not reach a conclusion.
We had put a lot of time and effort into the investigation, and we just weren't sure what had happened.
Less than 2 years later, Greg Phillips and the NTSB would be brought back to the mysterious disaster with the crash of another 737.
Hold on. Hold on. Shoot!
What is this?
Oh, God, no!
September the 8th, 1994. US Air Flight 427 has crashed near Pittsburgh, killing everyone on board.
When we first arrived at the crash site, first of all, there was no aircraft there. There were only bits and pieces of the airplane. It wasn't really recognizable as an airplane.
Investigators begin to see that this crash is a mirror image of United Flight 585. On final approach, United 585 rolled right, while US Air 427 rolled left. Both crews are caught by surprise. After a terrifying struggle, both crash with no survivors. Once again, investigators test the dual servo valve, but they come up empty-handed.
That unit passed all its operational tests. There wasn't any indication that it had failed.
We were going up against an aircraft that had an incredible safety history. It was really everything you could see for 30 years. This has been a great airplane. We were trying to prove that there was something wrong with the straight-A student.
The team reaches another dead end. But almost 2 years later, they get a third chance to solve this deadly mystery. In Phoenix, Arizona, a long night of maintenance is winding down. Over 30 mechanics and some half a dozen inspectors have combed through a Southwest Airlines 737. The team has made more than 400 separate checks. Parts have been replaced. Southwest 737 N427WN is almost ready to fly again.
Hopefully it'll push back out of the hangar. We'll do some leak checks, make sure everything's working, nothing's leaking, and then we'll go to the gate for departure time.
But it's a truth in maintenance that engineers can only fix what they know is broken. For several years, every 737 that flew had a hidden danger that not even the most careful technician could have spotted. In the early 1990s, two 737s crashed in mysterious accidents. In both cases, the jets spiraled out of control. In 1996, the same malfunction strikes again. It's June the 9th. Captain Brian Bishop prepares to land in Richmond, Virginia. Then, just like United 585 and US Air 427, his plane rolls out of control.
I turned the yoke the opposite direction and stood on the opposite rudder pedal. Now, the pedal didn't move for me. We didn't know to what extent, but we knew we had a problem with the rudder.
For over 30 seconds, Bishop struggles to control his renegade plane. And then, just as suddenly, the 737 calms down and goes back to horizontal.
We had started the checklist almost before I could finish the sentence. All of a sudden, there was just a wham.
The 737 is once again out of control. Then, out of the blue, Eastwind 517 is back on track. Wasting no time, Captain Bishop gets it onto the tarmac.
Taxiing in is when I realized my legs were shaking.
We launched to the scene. The airplane literally didn't move. Stayed at its location in the airport until we got down there.
Suddenly they had a 737 that had a rudder incident that was intact, and they had a pilot who was alive and who could talk about it.
I think they were much happier to have the airplane than me.
Investigators zero in on the 737's rudder controls. The power control unit is tested again and again, but it performs perfectly. Refusing to give up, investigator Tom Houter decides to try a different test.
One fellow mentioned a test they had done in the military of a thermal shock.
The power control unit is soaked in dry ice and blasted with nitrogen gas at minus 40 degrees Celsius. Then it's injected with superheated hydraulic fluid. It's then given a command to start working.
As we were standing there listening to the actuator move left and right, it stopped. And it was not commanded to stop.
It just jammed. It stopped working completely.
The team has discovered that a small hydraulic valve that controls the rudder of the world's most popular jetliner can jam in the right circumstances. And the valve can jam without leaving behind any traces. When investigators double-check their results, they discover another major flaw.
Careful analysis of the data, a couple of the engineers recognized that it not only stopped working, but actually left became right and right became left. There was actually a movement of fluid into places that it shouldn't have gone.
And the reversal is like driving your car. You turn to the right, it goes left. You're not going to figure out this failure mode until you go off the road. And in these cases, that's the pilots were faced with, something so unusual that they didn't understand what was happening.
What the hell is this?
That would explain why the first officer, Chuck Emmett, would keep his foot on the rudder pedal, because he's thinking, why isn't the plane going right? And he's feeling the plane go to the left.
In the aftermath of these disasters, pilots received better training on how to deal with sudden rudder problems. Boeing spent hundreds of millions of dollars redesigning and replacing the rudder's dual servo valve on thousands of 737s around the world.
One thing we don't like at the safety board is to have an undetermined accident, because then we can't make a change to improve safety. So out of US Air 427, United 585, we have a much safer 737 fleet.
It's 7 a.m. After an 8-hour shift, the maintenance is finished on this Southwest Airlines 737. According to their maintenance reports, the team has conducted 78 unscheduled procedures and 339 scheduled inspections.
I think each one of us out here has a sense of pride in themselves that we do the best job we possibly can day in, day out. Obviously, the stakes are high. Every life is important.
Despite the horror of airplane disasters, they're still extremely rare, especially given how often passenger planes take off and land.
Sometimes we obscure the fact that we fly millions and millions and millions of people day in and day out without putting a scratch on even the airplane, let alone the people. This is the most amazing system.
This system depends on the dedicated team of professionals committed to taking care of these 21st century masterpieces. Planes so well built that they could fly almost as long as we're willing to take care of them.
We've learned now how to inspect and maintain these things and even rebuild them to where they should have an indefinite life. They're built tough and they should be able to last forever if they're maintained properly.